Okay, today we're going to talk about a basic part that we're going to mill out on our Haas TM1 milling machine. This is a basic project right here that will teach you the very basics of CNC milling. We have this part drawn in SolidWorks. One of our students here at the Leominster High School drew this for us. And we also have what we call G-code, which is part geometry that will tell the machine where the cutter to actually move in an X, Y, and Z locations. So the first thing that I want to do when I look at a project like this, I want to see where my 0 point is, where my datum point is. And on this project, our datum point is in the top left-hand corner. That is a very common place for a datum point to be. Now, I have to decide as a CNC programmer how I want to cut this project out. Well, I'm thinking that I want to start with my cutter at this point right here. Now, I have to give that part an X, Y location. Well, I want to start directly in line with this surface right here that I'm going to cut out, and I know that that surface from our X0 is 150 thousandths over in this location. I know my part is 2 inches long just by looking at this dimension right here, and I'm going to add an additional inch. Now, why do I want to add an additional inch? Well, I want my cutter to come down off the part. I do not want it to plunge into the part. I want it to come down in a safe area where it's not going to make any contact with the part when it goes below the part surface. So that is the point that I want to go to. And then looking at this print, I want to cut this going clockwise around the part to machine those edges that you see. Now, you might get a better 3D visual on this isometric drawing up here. So you can see that there is a step down right here, all the way around the part. And that step down is 100 thousandths of an inch. On this program right here, I'm going to go over the very basics of this program. G20 tells the machine that we're cutting in inches. G21 will tell the machine we're cutting in millimeters. But today, this program and this blueprint is drawn in inches, so we're going to cut in inches. We have a safety line. The second line is always a safety line. It's actually turning off the switches on the machine from previous programs. It's very common to put a safety line in there. I will not go over those at this point, but I will continue down my program here. The third line, I'm going to use tool 4. I know for a fact in the machine I have a 5/8 end mill in tool 4. So I have to tell it what tool to grab because I have 10 tools in that machine right now. So I'm going to say tool 4, M6 says do it. M6 is a code that actually tells the machine to do something. Okay? To do a tool change, it is M6. So I'm calling up tool 4 and M6X do it. Now, the next line is a very important line. G00 always means rapid. There's two ways of moving in a CNC milling machine. In a rapid mode, which most machines move at a minimum of 75 inches a minute, which is very, very fast, or G01, which says move in a linear feed rate. And linear is a straight line. It could be a straight line on an angle, long as it is straight. So what I'm doing right now is I'm rapiding over using absolute coordinates. Absolute coordinates means all the dimensions on our program are coming from a fixed 0 point. And we said our fixed 0 point is right here, X0, Y0. G54 says I am using work coordinate 54. Now I could have 10 parts on the machine. Each part has an individual work coordinate. and it starts at 54, then it goes to 55, 56, 57, and so on. I am using work coordinate 54. We were already in the machine, the part is already set up, our 0 point is already picked up for right here under work coordinate 54, and you have to tell the machine or the program what work coordinate is. Now, the first move that I'm going to make, I am going to go to x of negative 150 thousandths, y of negative 3 inches. Where is that? If this line is being 0, I am going over 150 thousandths, which it says up here, and y negative 1 inch. From here down to here is 1 inch. The part is 2. I said go down an additional 1. So that's where I am starting from right there. Also on this line, A0, which means if I have a rotary table in there, that means move your rotary table to 0 degrees. I'm not running a rotary table right now, but by default or out of habit, I always tell the machine to set the rotary table at 0, just in case. Just in case your rotary table is off a little bit and you happen to be using it. I have to put a spindle speed on that line. M3 says, well, if I'm running my spindle speed at 1600 RPMs, M3 says turn on clockwise. There are 2 ways of turning on, clockwise and counterclockwise. Counterclockwise is M4. Line 5. Line 5 says G43, that means grab all the tool information, the tool height information from tool 4. You see where the H is? H means height. In the controller, all your tools are under different numbers, and your H number, which is tool 4, and your T have to be the same. If they do not match, you'll get an alarm. So if you're running tool 5, you have to say grab all the information from H5. But in our case right here, we're running tool 4, grab all the information from tool 4. On that line also it says Z.100. That means wrap it down to 100 thousandths above the part now. M8, turn the coolant on. Okay, I'm going to be running coolant on this part. So you have to tell the machine to turn it on. If you want to turn it on manually, there is a button on the machine, but I like to tell it to turn on in the program. Okay. Line 6, I have to tell it where to go. Well, the Z depth on our part from this surface here down to that surface there is 100 thousandths. So from this surface right here to here is 100 thousandths. I have to tell the machine to go down 100 thousandths deep. I just did that, and I also gave it a feed rate of 9.6 inches per minute. It's a calculated feed rate. We have formulas for that. Okay, now we are down 100 thousandths below this surface. We're ready to start cutting. Our first move is going to come right over to here. We're going to go to point 1. So what is point 1? Those are the coordinates for point 1 right there. So I said, move in a straight line. I also told the machine to cut on the left side of the line. Okay, if I had a cutter, and my cutter is 5/8 of an inch in diameter, I want that cutter to be on the left side of this line when it's going up. If I don't tell it to go on the left side of the line, it's going to cut right from the center of your part, your cutter. It's going to cut right up here. So what is it going to do? That would be your cutter right there. Half of it will be on the left side of the line, half of it will be on the right. So your part's going to come out smaller than you wish. So you have to tell it what side of the line to cut on. I told it G41 says cut on the left. G42 says cut on the right. So with those two G codes, you have to tell the machine, grab all the information from tool 4. That will tell you in the controller, tool 4 I have programmed for 5/8 of an inch diameter. So I told the machine I have a 5/8 cutter in that machine right now. So it's going to calculate half of 5/8, and it's going to move, as it's coming here, it's going to move over, so it's on the left side of that line.
All right, we're rolling.
Okay, on line 800, right here, you have to tell it now we went to this point. Now we have to give it the XY point here, 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 here. And as it's coming off, I want it to come off a little farther, over to there. So you have to give it all your XY coordinates. So this point 2 right here, we said y negative 580 thousandths. Where did I grab that information? This dimension right here. It's 580 thousandths from here down to that point. Now we're cutting an angle. We're cutting over to this point right here. We have to give it an x and a y. My x is 540 thousandths, and our y is 200. There it is right there. So all you're doing is going from point to point to point to point to point. Part geometry. At the very end, okay, right now our last command is it says to come off an inch off the part x negative 1 inch. And that's what this point is right here. So I said to come off the part. Now, I always like to start and stop in the same spot. So that means it's going to come right back to where it started and stopped. And that point right here, I said cut in a straight line. What G40 says now is we told it to cut on the left side of the line with G41. Now as it's coming back, you're going to shut off what they call cutter compensation. Okay? And that's what G40 is. And you give it your X and your Y location, where you're going to. And that's what we gave it right here. We said it was 150 thousandths over, and we said it's 3 inches down. G00, it says wrap it up to 1/4 inch above the part, so it's actually going to come up 1/4 inch above the surface. And now G91, G28, Z0 says go home. Okay, now we have 5 holes that we actually have to put in this part. Okay, in our program right here, we talked about this first line up top where it says wrap it over using absolute coordinates from a fixed 0 point. Using work coordinate 54, this is work coordinate 54. At that point right there, we picked it up with our probe. We have to tell the machine where to move to start drilling the holes. So we know the center hole of this location right here is in the X 1 inch 410 thousandths, and in the Y is negative 840, which we told it right here. We told it an RPM of 1500, and M3 says turn the spindle on. Now, G43 says grab all the tool information from H, which means tool, because you cannot put tool twice in a program. You can't put a T in a T. So H stands for height. Grab all the information from tool 6. Z says wrap it down to 100 thousandths above the part and turn the coolant on. Now, we want to do what we call Pect drilling. Pect drilling is just pecking down a little bit at a time, and it's a deep hole drilling cycle. So I can control the depth of the peck. Now, by controlling the depth of the peck, G83 says use your Pect drilling cycle. Q, followed by Q, it says how much of a peck do you want to take every time. Well, I would like, speaking from experience, I would like to take 50 thousandths at a time off. And that's what the Q stands for. R, so every time it goes down, it means return plane. So every time it goes down 50, it will return up to 100 thousandths above this part surface. Before it goes back down again and goes down another 50, returns back up to above the part surface. You have to give it a feed rate, which we calculated, and you have to give it a total depth. I said go down 250 thousandths total. Now, I have a series of holes, a bolt hole circle. So instead of calculating out the XY location of every hole, I can follow this Pect drilling cycle by what they call G70. G70 stands for bolt hole circle. Drill a bolt hole circle. The I on this line right here says, what is the distance from the center of the circle of your bolt circle to the first hole? It says 420 thousandths. You have to give it 420. J means where's my start angle? Okay, I could actually start at this point up here, which is roughly, let's say 45 degrees. So my start angle would be 45. So I would say J45. But for this program right here, I said J0 because 0 is always 3 o'clock, or 3 o'clock is always 0. 4 is the number of holes in your bolt hole circle. After that, I said G80, which says shut off the Pect drilling cycle, wrap it up to a ½ inch above the part, shut my coolant off. M5 says shut the spindle down now. Okay? And G91, G28, G0 says go home in the Z location, and then G28, Y0 says go home in the Y location. M30, end of program. I am all done. So that is a program to mill the part around the OD and to drill a bolt hole circle. Now we're going to head out to the shop. You guys got to actually see the whole thing run.